to 0. Therefore, if I factor out what's common in each of the expression, I'll have x into x minus 6, and then plus here I'll factor out 1, which is x minus 6 is equals to 0. I'll go ahead and now say this can be written as x plus 1 and x minus 6 is equals to 0. So that means that x is equals to minus 1 or x is equals to 6. That's one of the solution for this particular modulus. Then now we shall go ahead and also work out what's the solution of this other part that we have here. This is going to be x squared minus 5x plus 6 is equals to 0. Which two numbers, if I add them, the sum is going to be equals to minus 5, but the product is going to be equals to positive 6. Which two numbers will sum with that? In that case, we are going to take minus 2 and minus 3. These are the two numbers. So that minus 2 times minus 3 is going to give us positive 6. If we add minus 2 plus minus 3, it's going to give us minus 5. So meaning the middle term here can be written in terms of these two numbers we have, and that's going to be x squared minus 2x minus 3x plus 6 is equals to 0. We can be able to factor what's common in each of the case here, and that is going to be x minus x into brackets x minus 2. Here I'll factor out 3 so that I'll have x minus 2 is equals to 0. So finally we shall have x minus 3 into x minus 2 is equals to 0. Either this part and this part is equals to 0. So this is x is equals to 3 or x is equals to positive 2. So you can see now this result for this particular modulus that we have at this point is going to result to that. That's basically what you are supposed to do when it comes to working out questions to do with modulus functions. Another question we're going to look at is differentiation. How do you differentiate expression? If you are given an expression like this, you are told in part A, differentiate. We are going to differentiate sine x plus cos x divided by e is to 1 minus 3x. How do you differentiate an expression that looks like this? So here, what you need to remember is that this is a question to do with quotient rule. So we're going to say u is going to be sine x plus cos x. That is u. And then we are going to take v is equals to e is to negative, this is going to be 1 minus 3x. Now with this, you are going to say du dx is going to, if you differentiate sine, that's going to be cos x. If you differentiate cos, that's going to be minus sine x. If you differentiate an exponent, you usually differentiate the power, then you multiply it in front of the function. So this is going to be equals to dv dx is going to be differentiating the top. We are going to get negative 3, because if you differentiate 1, it will be 0. Differentiating negative 3x, that becomes negative 3. Then we shall have exponent 1 minus 3x the way it was. Then at this point now, we can be able to apply quotient rule. If you're having d of dx of u over v, quotient rule claims that this is going to be v du dx minus u dv dx divided by v squared. That is how quotient rule basically states. So if you have this formula well inscribed in your mind, then we can be able to apply that. So we are going to say our expression now will be dy dx is going to translate what? This is going to translate to v du. V, remember, it was e is to 1 negative 3x times du dx. Du dx is cos x minus sin x. Then the next term it will be minus u, but u was sin x plus cos x. Then this one is going to be times, we are going to multiply here by dv dx, and dv dx is this part that is well seated here, minus 3 e is to 1 minus 3x. I believe you can be able to see that that point here. Yeah. Then we're going to divide everything that we have in front of this by v squared, but v was that, so it's going to be e is to 1 minus 3x raised to power 2. Of course, you can decide and have your expression that way, but still we can be able to do it much better. We can be able to simplify that expression further by saying that dy dx can be written as this expression. We are going to factor out exponent. So if we factor out the exponent, what are we going to have? We're going to have e is to e is to 1 minus 3x. We are factoring the exponent out. We remain inside the bracket with cos x minus sin x. I think that space is not going to be enough. I have a little bit give myself quite enough space. This is going to be dy dx is equals to, I'll take the exponent out, 1 minus 3x into bracket. So I'll take cos x minus sin x, cos x minus sin x, and this other part here, it will be minus 3 to be now positive. And of course, because I have minus 3 here, this part here is going to be positive. So I shall have plus sin, I'll have here 3 sin x plus 3 cos x. Then I can divide everything by e 1 minus 3x times e 1 minus 3x. Because this is square, that is why I'm having that, so that I can cancel these two together. And then we end up having dy dx, which is going to be cos, if we are having cos x, and this is going to end up becoming 4 cos x. We are having cos x and 3 cos x here is going to become 4 cos x minus sin x plus 3 sin x. That's going to translate to plus 2 sin x divided by e is to 1 minus 3x. So that's what we have here. And of course, we can say this can be written as 2 e is to 3x minus 1 into bracket 2 cos x plus sin x. So this could be the final simplified expression in this particular question. But otherwise, if you are done this question and you leave it at this particular level, still you get your all your marks according to additional math. In this particular question here, students were told to solve the following simultaneous equations, and we're going to see which are the steps you're going to follow in order to solve such kind of simultaneous equations. If you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. So let's dive in so that we can be able to work out this question. Now, we are going to substitute. We are going anywhere. We are going to have x, we are going to substitute 1 minus 6y. So in this case, we are going to say that this expression is going to be 1 minus 6y. Because I'm having an x, I'm going to substitute this guy that I'm having here. So over 2y minus 4y over, instead of writing x, I write 1 minus 6y is equals to -1. Now, once I've done that particular step, the next thing is all true. I need to multiply by 1 minus 6y, all true. Every term multiply to that. So this is going to be this side and this side. I'm going to multiply by 1 minus 6y, and also this side I'll multiply 1 minus 6y. At that point of time, I'll have to agree, or you have to agree with me, that this part we're having here is going to be 1 minus 6y squared. This time this will be that, over 2y is equals to, if I multiply this term with this term that we have at this point, this will cancel with this particular value. So we are going to remain with 4y at that point is equals to -1 into 1 minus 6y. Once I've done that, again, I'm going to multiply all through by this value that I'm having here, 2y. I'm going to multiply to every term, and if I multiply it here, this is going to be 2y here times 2y there times 2y at that given point. But this and this one is going to cancel out. Then we shall remain the expression being 1 minus 6y raised to power 2 minus, this time this is going to be basically it is going to translate to 8y squared is equals to this, and this will be -2y. So -2y times this will be minus 2y. -2y times this one will be positive 12y squared at that point. So next we are going to expand this part that we have, and this is going to be, whenever you are squaring, just square the expanding an expression like this, square the first term, and that is going to be 1. Multiply the first term here and this one. What's the answer? That will be minus 6 times 2. It will be minus 12y. Square this term that we have there. We shall have plus 36y squared. Then we have minus 8y squared is equals to minus 2y plus 12y squared. Now, if we put the like terms together here, we shall have this translating to 24. This minus this will be basically 36 minus that. That would be 28. 28, we subtract 12. That is going to translate to what? 28 subtract 12. We are going to get 16. So we shall have 16y squared. Then let's talk of the y's. Here we have minus 12. And then if this comes here, we're going to have minus 10. Minus 10y. And then we have the value at this point, which is constant 1 is equals to 0. I believe everything is the way it should be up to that particular point. And in order to solve this, you can be able to use a quadratic formula and solve the simultaneous question. So we are going to check if you solve this using a quadratic formula, what are you going to get? And can you check if we can be able to use factorization? Sum is equals to minus 10. Product is going to be equals to 16. Two numbers. And that could be 8, negative, and negative 2. Yeah, you can be able to use that. So this expression now is going to reduce to what? Let's see. If we factorize that, we are going to have this as 16y squared minus 8y minus 2y then plus 1 is equals to 0. We factor out what's common in each of the section here. So this is going to be 8y common. We shall remain with 2y minus 1. And we factor out minus 1. So we shall have 2y minus 1. Let's check here. This is minus. We are factoring out. What are we factoring out here? See if we factor out that, what are we getting? So this is the minus 2y plus 1 is equals to 0. So this is going to be 8y into 2y minus 1, and this is going to be minus 1 into 2y minus 1 is equals to 0. So meaning that we can say this is going to reduce to 8y minus 1 into 2y minus 1 is equals to 0. And then we can say 8y minus 1 is equals to 0, which means that y is equals to 1 over 8. And also 2y minus 1 is equals to 0. So 2y is equals to 1 divided by 2, divide by 2. Y is equals to 1 over 2. And then now when y is 1 over 8, we can be able to find x. So x is going to be equals to 1 minus 6 over, 6 over, or 1 over 8 there, which is going to be 1 minus 6 over 8, which is going to be 2 over 8, which is going to be 1 over 4. And this is going to be our x in this case is going to be giving us 1 minus 6 into 1 over 2, and that is going to be giving us, this will be 3, so this is going to be minus 2 as the final answer. So basically, whenever you're given a question to do with simultaneous equations in additional math, basically that's what you're going to do. If you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. If you're given a question to do with logarithms and you are asked to solve for x in that case, at this point what we're going to say, let log x base 2 be equal to m. That's the first thing that we're going to say. Then we're going to say, therefore, this is going to be m minus 4 is equals to 5 times 1 over m, because you see at this point the base is switched with the number that is here. So if we were having x base 2 and this is 2 base x, then it means they are the reciprocal of each other. So which means that we are going to have this 1 over m because log x base 2 was m. Then if we multiply all through, by m, then we are going to have a quadratic equation. This is going to be m squared minus 4m is equals to 5, which is going to translate to m squared minus 4m minus 5 is equals to 0. So which means that we need to find two numbers whose sum is equals to minus 4, but product of the two numbers is equals to minus 5. Which numbers are those? The two numbers are minus, we can say it's 1 and minus 5. The two numbers are 1 and minus 5, so that if you multiply 1 times minus 5, you get minus 5, but 1 plus minus 4 is going to give us a value of minus 4. So this expression can be written as m squared minus 5m plus m, because it's 1m minus 5 is equals to 0 at that point. So therefore we can say this is going to be m minus 5. We can factor m out, plus 1 factored out for these two. We are going to have m minus 5 is equals to 0 at that level. Then we can now go ahead in order to solve for this. We can be able to say this can simplify to, what's going to be simplified to become m plus 1, m minus 5 is equals to 0 as the equation. Therefore m is equals to 1 negative, because this equals to 0 will give us 1 is equals to m, and this equals to 0. M is equals to what? M is equals to 5. So remember, we had said log, we are finding x, we are not finding m. We had said log x base 2 is equals to m. So meaning that we can be able to say log x base 2 is equals to minus 1. In index notation, this is going to be x is equals to this raised to power this, it will be 2 raised to power negative 1, which is equal to 1 over 2. And the second solution is when we have m is equals to 5. So we are going to say log of x base 2 is equals to 5. So this is going to be 2. X is going to be equals to 2 raised to power 5, and that is going to be 32 at that particular point. So whenever you're given a question to do with logarithmic equations, this is the way you are going to do it in additional math. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. Okay.